So welcome everybody, and thanks for joining us. We just have a couple of announcements to make before we jump into the program with Nate Senner. So Debbie, if you want to give me the announcement. Yeah, so we did have two Voxus Swifts events earlier in April. We did the first Friday and the second Friday. You might recall it was very cool weather, and the first night we only saw about 49 birds, which is not very many swifts, but frankly, we were thrilled to see anything because it was so cold. And then the second time that we went, we saw 64 birds. So there was still pretty minimal numbers showing up over those first 2 weeks in April. But last Saturday night, Barbara Combs counted 2,209. So now that we have some nice warm weather, the Voxus Swifts are here. And so actually, if we weren't doing this tonight, I would be down at Agate trying to check out the numbers for Voxus Swifts, but I think we're going to go down tomorrow night. So I encourage you strongly to go down to Agate Hall, 17th and Agate on the U of O campus. We have notice about that on Facebook, and it's great fun. Take the family, take people who aren't necessarily bird watchers, and you'll all be amazed. So don't miss it. That's my announcement.
Well, as Maeve has pointed out, it is migration season. The latest forecast is that there are going to be, I believe, 5 million birds flying over the state of Oregon in the next couple of nights. So let's remember what we can do to help migrating birds. Sorry, I put this very busy thing on and forgot to take it off. How to stop birds from hitting your window. Just a reminder, collisions with windows kill billions of birds globally. So we want to do what we can to help. Birds don't see glass, so they crash into them. Anything that you can do to create a visual barrier will help. So just some examples here. There's all kinds of products on the market. You can use tempera paint, you can use stippling, you can use screens. If you visit flap.org or go on to the American Bird Conservancy or Audubon site, there will be lots of tips for how to prevent birds from colliding into glass. Please do what you can. And also to keep birds along their migratory path, try and turn out any unnecessary lights. And if you have any lights in your yard, make them security lights pointed downward and shielded above, because we want the birds to go on their merry way as safely as possible. So just a reminder that it's the time that the birds are migrating, and let's do what we can to help them along the way. Thank you. I'm going to turn it over to Dennis.
I wanted to tell you about our speaker coming up in May. We're going to have Rick Ahrens. Rick, many of you know him. He's a local birder. He came here in 1981. And he's kind of a naturalist, a generalist who also knows a lot about the birds. And so we're really glad to have him. He has spoken at Lane County Audubon Society meetings several times in the past. And during the middle of the pandemic, I talked to Rick about possibly doing a program. And he mentioned doing Hawaii birds. And I thought that was just fantastic. You know, we're in this pandemic and we can't travel anywhere, and we kind of want to go somewhere. And the idea of even vicariously going to Hawaii to see the birds with Rick Ahrens just sounded fantastic. So I got him lined up. He'll be talking to us on May 25th, and we're real excited to have it. So May 25th, Rick Ahrens. Now I want to tell you a little bit about tonight's speaker, Nate Senner. He grew up in Alaska, graduated from Carleton College, and then with a Watson scholarship, he traveled all the way to the southern tip of South America and back, following the migration of the Hudsonian godwit. After he had done this migration with the godwits, he came to Eugene. And that's where I met him. We did several Christmas bird counts together, including the Florence bird count and Eugene bird count a couple of times. And so I got to know him quite well. He went from here to Cornell University, where he got his doctorate in ornithology. And from Cornell, he went to Europe and did a few other things. Oh, I wanted to mention, while he was at Cornell, he worked with Dr. John Fitzpatrick. Many of you probably know that name. He's well known in the eBird and birding community. So he continued his education in Europe and then Montana, and eventually at the University of South Carolina, where he is now assistant professor in the biology department, teaching ornithology. So I kept in touch with Nate over the years, and I thought, well, you know, we're having these Zoom meetings. We can have speakers from anywhere in the world. So I contacted Nate in South Carolina and said, Nate, what do you think about doing a program for us? Thinking he'd probably tell us about the Hudsonian godwits. But he had this great idea about flamingos in the Altiplano of Chile, a place I've never been to, the Altiplano in Chile, but I've been to the one in Bolivia. Fantastic place. And flamingos, holy cow, you can't get a more amazing bird, beautiful. And there are 3 different species of flamingos in this one area where Nate went. So real excited about this. So I think without any more, I'm gonna hand it over to Nate so he can take us to the Altiplano. Take it over, Nate.
Thanks, Dennis. I really appreciate the flexibility of everyone who's been able to make it tonight. After last night, I was stuck out on a barrier island off the coast of South Carolina, trying to catch whimbrel and unfortunately failing. But here I am tonight, happy to talk to all of you and really happy to virtually at least see some familiar faces. So Dennis did a great introduction, stole a little bit of my thunder, but I'll just recap because I did want to sort of walk through a little bit of history and link up my story with how I wound up in Eugene and then where I've been since then. So I started birding at a very early age. My father happens to be a biologist as well, and he used to run the Hawk Mountain Sanctuary in eastern Pennsylvania, and you can see here that he had me properly outfitted with binoculars and a birding hat and backpack at a very, very young age. Although if you stare closely at that photo, you can tell I'm actually looking through the binoculars backwards. So whether I could identify anything or not at that age is highly questionable. But when I was about 8, we moved up to Alaska, and I was thereafter maybe shoved out the door a little bit and sent off to work in the remote corners of the state with some really amazing biologists. And that really launched my career from being just a bird watcher into being a scientist. And so every summer during junior high and high school, I trekked off to a different spot. And this picture happens to be from the Noatak River Delta out in Western Alaska, holding a bristlethied curlew that we were about to put a satellite transmitter on. Actually, one of the very first satellite transmitters that was ever made that was small enough to put on something other than, say, a condor or albatross. So it was a pretty great way, I think, for me to spend those teenage years. And it then, as I said, launched me into being a scientist. And so as Dennis mentioned, when I graduated from college, I was lucky enough to win a fellowship that gave me funds for 1 year of research. And the stipulation of that research was that I had to spend the entire year outside of the United States. And so I chose to follow the migration of this bird, which flamingos aside, I'm still going to claim as the coolest bird in the world, the Hudsonian godwit. And what really drew my attention to godwits was that at the time, nobody knew how they made their way between their breeding grounds in subarctic and Arctic Alaska and Canada, and the very southern tip of South America. And so for my Watson year, I hitchhiked and took overnight buses the entire length of the continent and stopping over as many places as I could in order to try to figure out exactly where and when godwits were putting down. And those olden days, 2004, pre-eBird, pre-Google Earth, didn't really have a lot of information about where the birds were going. And I feel a little silly now because a lot of what I tried to do really could have been solved with those tools, but there's nothing that beats boots on the ground. And so I made this trek and came back whole, and found my way though to Eugene, where I decided to pursue my other passion, which is for long distance running. And so like many a 20-something-year-old, I tried my hand at training for the marathon in Eugene. And well, I found out that I was better at science than I was at running marathons. And so luckily, even during my time in Eugene, I was able to continue to dabble in biology. And that set me up, as Dennis mentioned, to go on to Cornell University in the Cornell Lab of Ornithology, where I took back up that Godwit obsession, and instead of just hitchhiking everywhere, actually put tracking devices on Godwits that told me where they were going and helped solve that mystery that I had started out exploring in my Watson year. But that research led me back down to South America, and to where I sort of want to start the story tonight. And that's on Isla Chiloé, which is an island about 2/3 of the way down the Chilean coast. It's quite a large island, and as you can see here, it's dotted by a large number of bays on that eastern side of the island. And those bays are characterized by lots of mud and really rich benthic ecosystems with mussels and crabs and clams, and just a smorgasbord for godwits, which are what you see in the very bottommost picture there. That's a flock of at least 10,000 birds that were amassed off the site at the very top of the map there, Chamisa, near the city of Puerto Montt. But as I was spending my time on Chiloé watching godwits, I have to admit that my eyes would always sort of wander upwards because there are mountains that are never too far from view, no matter where you are on Chiloé. And as my gaze wandered upwards, I recognized that by limiting myself to Chiloé, and maybe limiting myself to thinking about godwits a little too much, I was missing out on some really incredible ecosystems that in fact dominated much of the rest of Chile, because of course the Andean mountain chain runs the entire length of Chile and really forms the border between Chile and Argentina. And so I felt after a while, okay, it's time to explore some more. And so I was lucky enough to hook up with some colleagues who were doing some research up in the El Yeso Valley, which is just east of Santiago and sort of the very middle of the country. And the El Yeso is just a gorgeous area. It's also unfortunately characterized by a large reservoir that provides the water for Santiago. I mean, it's not bad that providing the water, but above the reservoir, very beautiful area. And my friends Fernando and Jim were working in the area to try to understand some of the really enigmatic high elevation Andean birds. So for those of you who haven't been down to that part of the world, some of those birds include this one, the gray-breasted seat snipe that we were able to find a nest here. The lovely and ubiquitous gray-hooded Sierra finch. The really cool tapaculo, relative of the wrens, the mustached turca. And of course, just for Dennis, because he specially requested it, the diademed sandpiper plover, which is in fact what my friends Fenya and Jim were there to study. And this is, as I said, a really enigmatic species that nests only in really high elevation bogs and flooded grasslands. And Fenya and Jim were putting color bands, like you can see on the legs of the bird there on the left, the adult, and finding their nests, and also putting color bands on their chicks, adorable little fluff balls. And I was lucky enough, just in order to make Dennis even more jealous, I was lucky enough to be there and help hold one that was clearly not very excited to be in my hand, and one that we let go very quickly, but we had just placed those little green color bands on their legs that you can see in the lower part just below my fingers. And what Fania and Jim were really trying to understand is where these diadem sandpiper plovers went during the Chilean winter, because the El Yeso Valley is under feet and feet of snow during the winter. And they found that most of them are going up further north into the Peruvian Andes, where they are able to escape some of that snow. So after this first taste for the Chilean mountains, I really needed some more. And so I ventured further northward onto the salares, or saline lakes, of northern Chile and Bolivia and Argentina. And if you are looking for truly austere beauty, I don't think you can do better than going to these salares. Just magnificent landscapes and also magnificent birds. Lesser rhea foraging around on the edges of the saline lakes, Andean avocets stalking in the water, and then, of course, flamingos. Although I love this photo because I'm not sure, I don't remember if the Vicuña photobombed a photo of the flamingos or if the flamingos happened to just be in the background for the Vicuña. But either way, this is a fairly characteristic sort of vision of the edge of these salares. And I also actually want to mention that all of these photos that I'm showing you here were taken by longtime student and now colleague Andy Johnson, who works in the multimedia division at the Cornell Lab of Ornithology. So, tremendous landscape, lots of really interesting birds. And as Dennis mentioned, there are 3 species of flamingos that can be found in these salares. 2 of them are in fact endemic to the region. So the Andean flamingo and James's flamingos, they breed nowhere else in the world. They do happen to sometimes spend the winter in lower elevation saline lakes, especially in Argentina, but they breed nowhere else in the world. And the Chilean flamingo does breed in some lowland areas in both Argentina and Chile, but nonetheless, the core of its range is also here in these salares in the northern Altiplano of Chile. So it's really a critical place for a number of birds. And that, of course, presents problems when we start to think about how ecosystems worldwide are changing. And even as remote and as austere as the Altiplano seems, it is changing rapidly as well. So for instance, the Atacama, which is one of the regions within this sort of larger part of northern Chile, has seen its human population more than triple over the past 40 years. Now, if you look there at the scale on the y-axis, that vertical axis, you'll notice that the population has gone from only 4,000 people to 12,000 people. So it's not like the crush of humanity is overtaking it, but nonetheless, change is happening. But the even bigger change has to do with things that we're actually doing up here in the US and what gets called the global north. And that has to do with lithium batteries and things like Toyota Priuses, which as great as they are things that, of course, require resources in order to create and keep moving. And lithium is one of those resources, and global demand for lithium has just skyrocketed over the past 40 years and is projected to increase at an even more rapid pace in the coming decade. And why do I mention lithium? Well, lithium, by and large, is mined in this part of the world, in the Chilean Altiplano. And in fact, the northwest corner of Argentina, northern Chile, and southwestern Bolivia is known as the Lithium Triangle and provides somewhere well above half of the world's lithium. And that lithium is in large part coming from these salares. So this is what a salar used to look like. And when sort of converted to lithium mining, this is what it looks like. So lithium production requires a really sort of complex process of refinement that in and of itself also requires lots and lots of water. And because this Altiplano region is so incredibly dry, that water has to come from these salares. And so we see this transformation of the landscape to these sort of square ponds of varying shades of green and yellow that are used for the refinement of lithium. And so this, presents some real problems for the water birds of the region. And in order to sort of understand why it's more potentially than just the transformation of the land itself that might be hurting these water birds, I want to talk a little bit about salt and what it does to the biology of organisms. So, as most of you are aware, or maybe all of us are aware, salt is a good thing in low doses, but generally not a great thing in high doses. And that's not just something that affects us as humans, it's something that is pretty universal. So most organisms have very consistent responses to salt. And if we're looking here on that vertical axis at the percent salinity, so the proportion of salt that is found in something, water can no longer dissolve any more salt at around 28% salt to water. Organisms, though, by and large, cannot live anywhere close to that salt saturation point. In fact, if we look at the sort of tolerance limits of organisms that are actually adapted to really saline environments, their tolerance really tops out at about 15% salinity. Above that, there are really only a couple of microbes that actually are able to continue to persist. But those are the tolerance limits. The actual optimal limits that even organisms adapted to saline environments really want to be within is this span between about 3% salinity and 7.5% salinity. So above that, again, they start to go into physiological stress. And below that, actually, when there's too much fresh water, saline adapted organisms don't do especially well either. But for our story, I think the most important thing is to think about those upper limits to both their optimal sort of life and what they can actually tolerate. And if we think about how birds actually deal with salt, you might be familiar with tube noses, Procellariformes like albatrosses and fulmars and all those sorts of famous seabirds. And that tube nose really refers to the way in which they're able to excrete salt because, of course, living in marine environments, they're encountering it all the time. But there aren't tube noses, by and large, found in other saline environments. And so other species, while they can deal with salt, have a much more difficult time. So even shorebirds that often spend, their time sort of on that edge in estuarine environments or on marine environments, when they have to deal with high salt loads, it rapidly increases what we call their basal metabolic rate. And basal metabolic rate is the amount of energy that an individual needs to just keep its body functioning at a very basic level. And so here what this graph is showing is that when a dunlin is acclimated to freshwater environments, its basal metabolic rate is substantially lower than it is if it's in brackish water environments or acclimated to full salt water like you would find in the ocean or the saltiest saline lake. So when there's too much salt in the environment, it poses real physiological constraints on pretty much all organisms. And this is important because as saline lakes start to lose water, whether it's because of warming temperatures and more evaporation, or because it's being used in things like lithium processing, it's not just that habitats shrink and there's less water for birds to move around in, it's also that the nature of that water itself changes and it leads to these physiological stresses. And we can see this if we look at what's been happening actually just in Eastern Oregon at Lake Abert. So Lake Abert is one of a number of saline lakes dotting the Great Basin. And it's the amount of water in Lake Abert has declined dramatically over the past 30 years. And as the amount of water has declined, the percent salinity has increased in kind. So that Lake Abert on average now is just way more salty than it used to be. And this is having really severe repercussions for the water birds and the lower trophic organisms on which they rely. So if we look at California gulls and brine flies, two really characteristic saline lake species, what we see is that their populations, their abundance really peaks at a very specific salinity level and lake level that you can see in these two graphs with those red lines. So they like salinity levels that actually correspond with about 5% salinity. And on either side of that salinity level, their populations decline really strongly. And if we look over on the left-hand edge of those graphs at where those red lines start to approach zero, that's when the salinity of Lake Ebert has risen above that 7.5% and is approaching 12 and sometimes 15%. And basically when the lake is that saline, neither brine flies nor California gulls are able to make use of it. And so we see that if we look across the water bird assemblage that makes use of Lake Ebert on a regular basis, that when the lake levels drop low enough and the salinity rises above that 7.5% threshold, water bird populations decline there by 68%. So that's really, really dramatic. And that's not saying all these birds die. It's likely that they just simply move somewhere else, but it still means that they've had to move away from the place that they would otherwise be making use of. Okay, so let's come back to the Atacama and what's going on there as lithium mining has increased. My mouse stopped working. All right, the Salar de Atacama. So it's this big salar, big, huge saline lake that's there sort of nestled in between Argentina and Bolivia in the corner of Chile. And it's one, as I mentioned, of a series of salares that are along that northern portion of Chile. Oh, there, that arrow, I knew it was coming. So the Salar de Atacama, it's in the middle of the Atacama Desert, as the name might suggest. And as you probably know, this is the driest place on Earth. And so if we look at rainfall levels over the past 60 years or so, we see that on average, it gets about 20 millimeters of rain, which is just what, a normal December morning in Eugene. That's a whole year. And some years there have been far lower levels of precipitation across an entire year than that 20 millimeter average. So this is a truly dry place, which means that there's not a lot of sort of free water around. And so as lithium production has increased, which we can see here in this graph on the left, starting in about 1984, lithium mining began to be allowed in the Salar de Atacama, and it's risen substantially since that time to where now the only data that we're actually allowed, since most mining companies don't want to tell you how much they're actually mining, what we can see is that the amount of mining pond area is now over 8,000 hectares alone in the Salar de Atacama. And as that mining pond area has grown, so has the amount of water that they're actually taking out of the ground. And so the pumping rate has increased substantially over that time. And so along with a group of Chilean scientists and a hydrologist, or a couple of hydrologists from Montana, we've been trying to understand what kind of effects this increase in mining is having on those flamingo populations in the Salar de Atacama. And what we've done is that we've made use of flamingo counts that go all the way back to 1985 from the region that were taken by the Chilean government. And then we have also been able to use what's called sort of generally termed remote sensing data to measure flamingo food availability in these saline lakes without actually necessarily being on the ground. And we're able to do this because flamingos are sort of like whales. They're filter feeders, and they're actually eating really tiny things such as these brine shrimp that help to give them their pink coloration. And we can remote sense the food availability because much of what the flamingos are eating actually photosynthesizes, and we can detect photosynthesis from satellite imagery. So we use a measure that's called NDVI to sort of stand in as a proxy for flamingo food availability. And then finally, we have some other remote sensing data, some other satellite imagery that allows us to actually quantify how much water is available for the flamingos in a given year. So the way we can do that is we look here at sort of a color rectified satellite image, and we can see, you know, where that water is on the landscape. Of course, it's really set off against the dry desert that surrounds the salar. And then we can quantify the change from year to year in that amount of water. And using the same methodology, we can actually then also really quantify where those mining ponds have been built and how much water there is in them. So combining all these sources, we wanted to see what's going on with flamingo populations in the Atacama. And the first thing we found is that water levels have declined sharply in the salar. So since 1985, they've declined by more than 30% over that time. So there's just substantially less water available for flamingos. But interestingly, when we took an initial look at the number, in this case, of Andean flamingos that were using the Salar de Atacama, there was no clear trend. So at first we're like, oh, well, that's good, actually. Then maybe we don't need to get up in arms about all of this lithium mining. But when we started to think about it, we noticed that there are some really huge peaks and valleys in this graph. And so the fluctuations that we're seeing in their populations led us to question, well, is there maybe more to this story than might initially have met the eye? And so what we set out to do was to create a sort of a map of all of the potential relationships that might connect the environment with the number of flamingos that we could go out and count on a yearly basis. And so, for instance, we might hypothesize that precipitation and evapotranspiration are going to influence the amount of water that a lake might actually have in it at any moment in time. And we might also simultaneously predict that precipitation could influence the amount of flamingo food, because as I already told you, there's that relationship both between surface water and flamingo food, but also likely an additional effect of how much fresh water is entering the system. On top of that, we might imagine that, you know, as mining is increasing, it has a direct effect on flamingos, or it might have indirect effects, for instance, by taking away some of that water and contributing to how much water is actually available. So we put all of this together in what's known as a structural equation model that allows us to sort of pick apart the directionality of what is actually influencing what and whether or not those influences are positive or negative. So this sort of looks like a complex jumble of stuff, but hopefully it makes sense when you sort of look at it color-coded, because what we found is that yes, precipitation and evapotranspiration are influencing the amount of water in those saline lakes. And when there's more water, there's more flamingo food. And when there's more flamingo food, not surprisingly, there's more flamingos. But you also see that mining area right there is in a bright red box. And that's because it has a negative impact on both the amount of water and directly on flamingo abundance. And so then if we sort of control for all of these varying factors and look at try to just isolate how mining is influencing flamingo abundance, what we see is that in fact, over time, mining has caused a decline in flamingos in the Salar de Atacama. And especially it has caused a decline in Andean flamingos, where average counts there, given a sort of average water level, have declined by about 50% since 1985. And so as we look at a future in which lithium mining is going to become more and more prevalent, we're probably looking at a future where, at least in the Salar de Atacama, flamingos have less and less of the likelihood of thriving. But the Salar de Atacama is just one of the salares in northern Chile. So are flamingos sort of doomed at the species level, or is the problem potentially just isolated to the Atacama at the moment? So we took those same flamingo counts and that same sort of remote sensing approach that I talked about, and we then increased the spatial scale at which we were looking. So not only did we then look at the Atacama, we looked at 4 other salares as well: Pusa and Tara and Huasco and Sorire. And we created that same nest of hypothesized relationships among a whole bunch of variables. But we didn't have information on mining effects in those other salares because there's not yet mining going on. So it sort of acts as this control to see how different the Atacama is from everywhere else in the region. We did, though, however, look at whether the growing human population might be having an effect of its own. And interestingly, what we found is that there are very similar environmental relationships between the environment and flamingo numbers across these 5 salares, but that the human population was not yet influencing flamingo abundance anywhere outside of the Atacama. So once again, though, as there was more water and more flamingo food, there was more flamingos. And just to show you that in another way, this is a graph for each of those flamingo species, showing you how, as their food increases there along that horizontal axis, the number of flamingos there along the vertical axis increases dramatically. So flamingos really respond to food, which makes sense. And then if we look at flamingo numbers after we've controlled for all of these variables across the entire region, we still see some pretty dramatic fluctuations in their numbers from year to year, but we didn't see any large-scale decline in flamingo populations as of yet. So a good piece of news to walk away with. And the reason that we think that those declines that we witnessed in the Atacama are not affecting the wider region is that, in fact, flamingos aren't necessarily constrained to staying at any one salar, because conditions are so variable from year to year that they're likely moving amongst them as conditions might improve at any one of them at any given point in time. And so it's really this network of salares that flamingos are moving around between year to year. So then, just to wrap all of this up, what I think can take home is that across northern Chile, at least, flamingo populations appear to be stable. And that flamingo numbers are really driven by water availability and food. And I didn't really go into this, but interestingly, despite the slight differences in habitat use among the 3 flamingo species, they all seem to respond very similarly to both environmental and anthropogenic factors. And finally, that in the Atacama, mining is negatively affecting flamingo abundance, at least within that particular salar. So then as we look to the future, what do we see? Well, lithium production is projected to triple in the Atacama alone in the next decade, and there's now discussion of having significant lithium mining operations at a number of salares in Bolivia and Argentina. And we also see from some of saline lakes elsewhere in the world, like Lake Ebert, that there are these potentially non-linear dynamics that govern the relationship between environmental variables like water and salinity and bird populations. And so this means then that the potential combination of climate change and mining may prove really difficult for flamingos to deal with long term, especially as more and more salares begin to have lithium mining activities within them. And so I would say that we then really need to do some soul searching ourselves, because at large scales, few, if any, technologies are actually sustainable. And so as great as cars like hybrid vehicles are at potentially combating climate change, they cannot be seen as a panacea that will stop all of the environmental damage that we're currently wreaking on the globe. And instead, we have to try to think of other potentially non-technological approaches to how we might limit our impact on the world. And I think that's especially important as we listen to President Biden lay out how he believes we should address climate change, which largely focuses on getting more hybrid vehicles on the road, more electric vehicles on the road. And so there's already talk about a lithium mining boom in the Great Basin saline lakes. So not necessarily Great Salt Lake like we see here, but the string of saline lakes that are up and down the Great Basin and also elsewhere across the globe. Not surprisingly, saline lakes in China are already ramping up their lithium production. And all of these saline lakes really support each their own fairly unique water bird assemblage. So if we lose these saline lakes, we're going to lose an important portion of the world's wetland birds. So some good news from northern Chile at the moment, but potentially worse news on the horizon. And with that, I want to thank first the East Cascades Audubon Society and the Bureau of Land Management for the data from Lake Ebert, and then for the many observers who carried out the flamingo surveys over the past 30 years, especially the staff at CONAF in Antofagasta in Chile. And with that, I'd love to take any questions. Thank you all very much.
Wow, thank you very much, Nate. That was really amazing. I think I used to just think flamingos are very pretty birds. So that was really great. Thank you very much. Let's see if there are any questions out there. I can't see the chat thing if people type in things. Debbie, will you look at that and then read them off if there are any?
There are no questions right now.
Okay.
Here we do have one question, and please everybody feel free to speak up with your questions or just type them into the chat and we'll get Nate to answer them. Question from Ron and Beth: is there radioactive thorium in relation to the lithium found there?
Oh, I have no idea. I don't imagine that it's unique lithium, but I really, that is outside of my my scope of knowledge. Sorry. I think though that I saw Roger with his hand up.
Right.
Roger, just unmute yourself and talk.
Yeah. Yep, I'm unmuted.
Okay.
Yeah, thanks, Nate. I wondered if there had been any banding studies done on these flamingos to see if they actually did move from saline lake to saline lake and actually perhaps move into Bolivia as well.
Yeah, so there definitely has been some banding work, and there is a consortium of sort of flamingo, both biologists and enthusiasts that are in Peru and Bolivia and Chile. But that information really hasn't been synthesized yet. So I don't have a good answer for you of like what the real scope of their movements is on an interannual basis. I mean, we know that they're certainly capable of the movements. We see them, for instance, going down to lower elevation lakes in Argentina, but exactly how any one individual moves from year to year, I haven't seen that information anywhere yet.
Thanks.
Hi, Nate. This is Ron Larson.
Hi, Ron.
Hey, thanks for highlighting Lake Ebert.
Yes, and thank you for your work there.
Oh, you're welcome. In fact, I was there last week and we're going again tomorrow. We're trying to get some idea of what the bathymetry is like so we can do better water modeling. But I wanted to mention that unfortunately the lake has gotten very low in the last couple years.
Has it? Okay.
And the bird counts last summer were the lowest of any of the years.
Wow.
And, but one of the things that we've learned is that although the lake, you know, as you mentioned, gets very saline, and right now it's probably around 20 or 25 because the salt is already precipitating. But the birds are feeding along the shoreline in areas affected by springs. And so it seems that alkali fly larvae are persisting in these springs and allows, you know, some of the birds to feed okay. Now,
yeah, there could definitely be those microhabitats that retain the appropriate salinity.
yes, that's right. But
Yeah.
unfortunately, those areas are not very large. And when we get the large influx of Wilson's phalaropes and, you know, other birds this summer, I'm afraid there's not going to be much food for them.
That's not good news.
Yeah. I also wanted to mention that flamingos did live in Oregon. There's evidence of fossil flamingos occurring in Fossil Lake. That's
cool.
In Eastern Oregon.
Very cool.
Yeah. So thanks a lot for your presentation. That was excellent.
Thank you.
Well, there are no more questions. Is that right?
I'd like to ask one. This is Betsy Berg. When the population of flamingos is down at one saline lake in the Andes, are they up at one of the others?
Yes, so they seem to sort of be, I would say, out of phase with each other. Where if I go back here, you sort of have these southern three that you know, largely experience the same environmental conditions within a year. And then those northern two seem to largely be decoupled, to have their own sort of weather system and, you know, variation in precipitation. So what does seem to happen a little bit is that you have like an influx to the north, you know, or an influx to the south, depending on, you know, where conditions are better. And, you know, as I was mentioning when Roger was asking, are individuals moving? What we don't know is that largely driven by, you know, young birds that maybe hadn't ever bred before, going and deciding, I'm gonna, you know, breed for the first time in this new place, or is it those older individuals that are, you know, flexible enough to sort of track conditions within their lifetimes?
Thank you. And for the whole evening.
Oh, thanks. So I see another question in the chat. Do flamingos in the Atacama get down to Mar Chiquita, which is in the process of being designated a national park? A small bit of good news. Yes, absolutely. So you can see Andean flamingos and a few James flamingos down at Mar Chiquita, and this is in north central Argentina during the austral winter. And so absolutely, it's great news that a bit more of Mar Chiquita is being protected.
And on that note, Nate, are you aware of any organizations that are working toward legally protecting some of these areas where lithium mining might start happening as demand increases? In other words, is there a way to get out in front of it and protect some of these places?
Yeah, so there is, you know, there's this Flamingo consortium that I mentioned that's tri-national. There's a group in Chile, the Red de Observadores de Aves Chile, that is really spearheading some great sort of outreach efforts. But it's, you know, it's a big ask because the mining companies in Chile have just tremendous power, and you could listen to whole presentations on how water rights are dealt with, for instance, in Chile, so that mining companies can buy the water rights out from under people. And so it's a very complex situation that's in fact pitting local people and not just sort of bird lovers against, you know, some of these mining activities. But I haven't really heard of, you know, sort of yet successful upwellings to really counteract the increase in mining, because it's just bringing so much more money into the country, not to the local people, but into the country. That said, the Chilean government did designate Huasco, this salar right here, as one of 40 wetlands in the country that they felt was of such importance that it should be protected, which doesn't mean it actually has protected status yet, but it should be protected into the future.
I wanted to ask a question. I heard about an article about recycling lithium and trying to reduce the mining demand through recycling. And I'll share that on the Facebook page after this is over.
Great. Yeah, I talked, actually, a friend of mine works in Silicon Valley with some of, those companies there. And he said that there is awareness among some of the groups about, the need to really not just figure out more ways to use lithium, but better ways to use it. So there definitely is some movement afoot there.
So Nate, this is Ron Larson again. Looking at your graph of precipitation, it didn't look like there's any definite trends. Is climate change not really a factor there yet?
So I believe you were talking about way back here somewhere. Yeah. So actually in the Atacama itself, there has been some increase in precipitation over the past 20 to 30 years. My understanding from the hydrologists on our team is that that is not necessarily enough to counteract increased evapotranspiration and decreased snowmelt. So the real important thing for the water level in the salares is actually what's called groundwater, which is sort of happens on a much longer time scale and tends to be sort of things that trickle down, largely from snowpacks and whatnot. So yeah, there is sort of this increase in precipitation, but it's not anything that's going to overcome, I think, these other processes that are at work.
Thank you.
Well, and maybe we should all give a big hand to Nate for this wonderful program. And I'm really glad we were able to arrange to have it tonight. So thank you so much for providing this program to us, Nate. It was great.
Thank you all very much.
Thank you. That was excellent.
And I hope to make it back to Eugene sometime soon.
Okay. All right. We'll be, you're welcome here.
All right. Have a good night, everyone.
All right.
Okay.
Good
Good night, Nate. Good night, everybody.
That was great. Thank you. Good night, everybody. Thank you so much. That was great.